Good morning, learners. My name is Mr. Pochilola once again, your online teacher in physics, chemistry, biology, and mathematics. This is our week number 4 since we started learning online. Welcome to today's lesson. This is a lesson in physics in a topic called electrical resistance. Electrical resistance. And today we look at a very important aspect of electrical resistance, which is called resistor codes. Resistor codes. Alright? Resistor codes. So in today's lesson, in short, we are going to be looking at how you can determine the resistance of a fixed resistor. Alright? How you can calculate or determine the resistance of a fixed resistor. Remember that we have two types of resistors that are in common use, namely fixed resistors and variable resistors. Alright, so as the name suggests, fixed resistors are those resistors whose values you cannot change. You cannot change. They have a fixed resistance. Such resistors have a fixed resistance. Right? So from the manufacturer or where they are made, the values are fixed such that you cannot manipulate, you cannot change them. That's why they're called fixed resistors. Alright, so fixed resistors are coded, alright, they are marked with colors. Those colors are called resistor color codes. Resistor color codes. Alright, so given the codes, the colors on a particular resistor, you should be able to calculate. You should be able to calculate the resistance of such a fixed resistor. Right, by just looking at it, you can deduce. You can deduce the resistance, the total resistance of such a resistor. Okay? So the colors that are marked on such resistors are called resistor codes. Resistor codes, alright? So we use those codes to calculate the exact resistance, the exact opposition which such a resistor would actually subject on the electrical current flowing through it. Alright? So when you are given a resistor, fixed resistor, look at it closely, you find that there are colors on it. We call them color codes or bands as they are sometimes called. So you can use those codes to determine the exact resistance which such a resistor would subject to the electrical current flowing through it. Alright, so we are saying fixed resistors are marked with colors. What are those colors for? They are to tell us how much electrical resistance they could subject to the current flowing through them. Alright? For example, if you look at this resistor here, this is a resistor. Remember, this is a resistor, right? So we are saying it is coded with colors. It is coded with colors. For example, here, if you're good at telling colors, you can see this is brown, this is black, this must be red, this must be blue, and at the very end there, you have gold, something that is golden. If you look at the colors carefully, You see this is brown once again, black, this one something like red, blue, and gold at the end. So each of these colors has a value. So I'm going to show you how you can use the values to calculate the total resistance which the resistor has or subjects to the electrical current when connected in a circuit. So once again, this lesson is about calculating the total resistance given the color codes. The colors are different. They're different colors. You see, look at this resistor. It is differently coded from the other resistor and so on. Resistors do not have the same color codes. They are marked differently depending on the magnitude of their resistance. All right. So we are saying that each color is a code. Each of these colors, brown, black, red, blue, gold, is a code representing a unique value. All right. So each color is a code representing a unique value. So for example, brown has its unique value, black its own value, red its own value, blue its own value, as well as gold its own value. So that when we use these codes, color codes, we can actually determine the total resistance. We can determine the total resistance, and that's what this lesson is going to be looking at this morning. All right, so let me urge you to stay on, watch the video up to the end. You may take notes if you like, but as usual, I'll also send you PDF notes which you can refer to after watching the video. All right, so stay on so that you can grasp and get it from the word go. By the end of the lesson, make sure you are able to calculate the total resistance. Given the color codes, you can calculate the total resistance, and that's what we'll be doing in this lesson. So a standard fixed resistor has 4 colors. We are saying each fixed resistor, like the one we have here, has 4 colors. What do we use those colors for as we determine the total resistance of such a fixed resistor? Now, the first and second codes, here you see the first one here is brown, the second one is black. You count from left to right, okay? Left to right. Of course, you'd ask me to say, what if you rotate this resistor so that the first one is gold? All right, you can tell gold is if you lay this resistor on a bench, you can tell which side is your gold. So it is acceptable and the requirement to read your colors from the left hand side to the right hand side. Okay, so with that regard, we are saying the first and second codes, in this case the brown and black codes, give the first and second digits from the left. All right, we'll see how this can be done to determine the value of a resistor. So we are saying the first and second codes, the first color, the value of the first color, and the second color will give you the first and second digits. Let us suppose that this brown represents, just an example, right? It represents, say, a 3. So the first value will be a 3. Let's suppose the second value represents a 0. Then it will be 3, 0. Okay? 3, 0. So the first and the second codes give first and second digits from the left. The way you write a number. When you're writing a number, a big number, you start writing from the left, all right? So we're saying the first and second chords give the first and second digits from the left, okay, as I just said. All right, the third color code, in this case the red, this one here, the third color code gives the number of zeros, to be added to the two digits, the digits that you write here. So we are saying the first and the second chords give first and second digits. If this brown is 4 and this black is 2, then you have 24. But the third chord, which is this red here, suppose it is 6. That 6 represents the number of zeros which you have to add to the first and the second digits. Okay, I'll take you through an example where this can be appreciated practically. Now, the fourth color, in this case, the fourth color, look at this. So we have the first, second, third, fourth. All right, okay. So the fourth color, or the last color, let's not limit ourselves to saying fourth. No, because here you already see you have 4 color bands. So you have 1, 2, 3, 4. All right. But the last one there, which gives you what we call tolerance. Tolerance is just the percentage of the accuracy of a value of a resistor, which can be plus or minus. All right. For example, you see gold. Gold has a tolerance of plus or minus 5. What it means is that when you calculate the resistance of your resistor, you add that percentage. That percentage is called a tolerance. It's called a tolerance. I'm going to show you how this can be done. Now, for us to calculate resistance from a given resistor, we use a chart. We use a chart which gives a unique value for each color, like I said. Okay, so we have a chart or table that shows the value of each color on a fixed resistor. So the resistor we have here, for example, has the colors brown, black, red, blue, and gold. All right. So in order to calculate its resistance, we are saying that all the colors representing unique values of a fixed resistor are shown, as shown down here in a chart. Okay, so let's look at the chart. If you look at this chart here, all right, we have marked it. We have color, a row for color, and another row for values. Okay, so when you have a black color on a resistor, that black color stands for 0. All right, so we are looking at color and the numbers that they represent. All right, brown represents a 1, red represents a 2, orange represents a 3, yellow represents a 4, green represents a 5, blue represents a 6, while violet represents a 7, gray represents an 8, and white represents a 9. So these are the values of that represent, or that each color represents, when you have a resistor with color codes placed on it. Okay, so you can see here that the values are arranged in ascending order from 0 to 9. For example, here you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You see here there are 10 digits, including 0. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, black, brown, red, orange, yellow, green, blue, violet, gray, and white. Please take good note. Take good note of these things so that you appreciate how we can use them to calculate the resistance of a resistor. That's great. So we are going to find a way of memorizing this order of colors so that you can answer any question that requires you to work out the total resistance, although this may be given in an exam sometimes, all right? Okay, but for now, if you love physics that much, let's try find a means of memorizing these colors and their corresponding digits. So we are saying from 0 to 9, we have black, brown, red, orange, yellow, green, blue, violet, gray, and white. Take note of the order. Please don't mess up with the order. Don't mess up with the order, all right? As well as the values. As well as the values each color represents, okay? So let's look at how you can put this on your memory so that you can, at any time, when asked a question about color codes and how to calculate electrical resistance, you should be able to do that without any challenges. All right, I believe so far so good. So we are going to look at that in a while from now. We're going to look at how do you use the chart. But first of all, let's find a means of memorizing the color codes in order. All right, each color code represents a number, unique number. Okay, so how do you memorize? How do you remember the color codes of a fixed resistor? How can you remember all the 9 colors in order of their occurrence? All right, like I said before, you have colors from black, brown, red, orange, yellow, green, blue, violet, gray, and white. All right, from 0 to 9. Okay, that's what we have. So how can you easily remember these colors? Like, you tried in Form 1 or Form 2 to remember the colors of a rainbow using Roy Gibbs. Well, you remember Roy Gibbs? Yes, the 7 colors. You can easily use those the Roy Gibbs formula to find to list down the colors of a rainbow. So you can also use the same, the same mnemonic, right, to determine or to arrange the names of the colors of a resistor. Okay. All right. So, in order for you to remember the colors of resistors in order of their occurrence, you can use the following mnemonic. Mnemonic is a device, we call it a mnemonic device, is a way of remembering something very, very easily, all right? So you can use this mnemonic to help you remember the color codes of resistors in order. All right, so if you look at this, this looks like a sentence which you can form and say. All right, so let's look at it together. Let's read it together. Buster Brown races our young girls, but Violet generally wins. I'll say it again. Buster Brown races our young girls, but Violet generally wins. All right, so if you look at the first letter of each word, you find that each letter represents the 10 colors of resistors. All right. So I'll read this again. Buster Brown races our young girl. To race means to chase them or to compete with them in a race. Okay. But here, Violet generally wins. In general, Violet is the one who wins all the time. All right. So Buster Brown races our young girls, but Violet generally wins. So by doing that, you have listed all the colors from black to white. Okay, the rest you just substitute the values, just place the values under each of the letters, all right, in order to assign each color a unique value. All right. Now, I mentioned earlier on that some color codes represent tolerance. All right. So such color codes include red. If you have a red color at the end of the bands, that means the tolerance which you have to add to your resistance is 2%. It's 2%. If the color at the end of your resistor to the right is gold, then the tolerance value is going to be 5%, plus or minus, don't forget. So the resistance that you calculate, you add plus or minus 5%. If the color is silvery, we will have to add 10% to the calculated resistance. But if there's no other color at the end, then you add 20%. Please make sure you remember these color codes, which are uniquely used for tolerance, determination of tolerance. All right. So we are saying the color codes represent tolerance values. We call them tolerance values. All right. So in this case, the value that you get from the first colors before you get to the final color to your right, all right, you need to find or determine the percentage. This percentage is called tolerance value. We are going to look at an example explaining or showing you how you can use these to represent the resistance of a resistor. For example, let's look at this case here. We have a resistor, all right? Calculate the resistance of the resistor shown. So we have a resistor here, although it looks black, but I've labeled the bands, all right, the codes as red, black, blue, and at the far end there, you have gold. So let's calculate this together. Let's calculate the resistance of this resistor. Okay, so what you do is to determine the value of each resistor: red, black, blue, and at the far end we have gold, which is a tolerance, a color for tolerance. All right. Okay, so in this case, since we know from the chart that we had earlier on that red stands for 2, all right, black stands for 0, and blue stands for 6, while gold is 5% tolerance. And remember that the first and second colors represent the first and second digits respectively, while the third color represents the number of zeros which you have to add at the end of the first and second digits. All right, then whatever you find, you take a percentage of that. You add or subtract the percentage depending on the color code at the end of the resistor to your right. Okay, so in this case our resistance is going to be 2, why? Because red is the first one here. The value of a red is a 2. Mind you should not confuse this red with the one that comes to the far left. The one which comes to the far left represents the value that is assigned to it. So in this case, if you go back to the chart that we looked at earlier on, red represents a 2, all right? While black here represents 0, Blue represents 6. Gold represents 5%. All right. So the resistance of this resistor, therefore, is going to be 2, 0. Where am I getting the 2 from? The first one is red. Red on the chart we looked at earlier on, is represented by a 2. It represents a 2. All right. The second color, which is black, is 0. So you bring a 0 here. And then you wait a minute. Look at the third color. The third color. What is the third color? It's blue. But what is the value of blue? It is 6. So this 6 is telling you that you should add 6 zeros at the end of the first and second digits. So you have 1, 2, 3, 4, 5, 6. So that in the end you have 20 mega ohms. This is 20 mega ohms. 20 million ohms. This is the same as 20 mega ohms. Alright? But then, because we have a gold color at the end there, you have to add plus or minus 5%. So as easy as that, it's so easy to calculate resistance of a resistor, a fixed resistor in this case. Alright, I'm sure you are happy with this. You are so satisfied to calculate the resistance of a resistor from the color codes shown on it. So once again, the red which comes at the far left, this one here, represents a 2. So that 2 is right here. We just write the 2 there. While the second digit, the second color, represents the second digit that you have to write to the immediate right of the first digit. So black represents 0, so just bring the 0 here. But the third color, which is blue, this one, which is 6, represents the number of zeros that you have to add at the end of the first and second digits. To the far right there is gold. But what does gold stand for? It stands for a 5% tolerance. So when writing down the resistance, you have to say 20 million plus or minus percent. So remember, these are ohms, so don't forget to add an ohm there. All right. Okay, so we come to the end of our lesson today. We were looking at the use of color codes to calculate the resistance of a resistor. All right. So what now you are going to do is to work out the value of the resistance shown here. So we have a resistor that has brown, red, orange as the first colors. Then at the end, you have a tolerance of silver. So you go to the chart, check what value is represented by silver and what value is represented by brown, red, and orange. And then you compute or calculate the resistance of such a resistor. You do the same for this one. You have orange, yellow, red, and the tolerance is gold. Can you go ahead, calculate the resistance of these resistors? All right, so we stop here for today. You have been a wonderful audience to teach. All right, I wish you all the best, and I believe that you are working hard so that you make it in your exams that are around the corner. Once again, my name is Mr. Pochilola. I continue to be your teacher now, and when we are back to school. So for me, it's a big bye-bye.